All right, welcome to Python Frederick. This is March 2019. Tonight we're going to talk about Python testing 101 with pytest. I'm Matt Layman. I have information up there about who I am, but I'm or where you can find me, I guess, on the internet. But I'm a software engineer. I've been using Python for over a decade, so I think I know a thing or two about this language at this point. Gosh, I hope so. You guys can be the judge of that after we're done with the presentation. So we're going to talk about tests, and before we can, so at a high level, this talk is going to be focused on the what, the why, and mostly the how of testing. And I guess the who and the where is you and all the time, or when is all the time. But that's how I was phrasing this. So those core questions to kind of get us all centered around the same thing. So we got to start with what is a test, and I think this definition can vary, but do y'all have opinions about what you think a test is? Like, if you had to define a test without sneaking the side preview on the side of my slide earlier, what would you define a test as? Any thoughts?
Something that can save your butt when you're trying to push it to production.
Okay, so like a safety net?
Yeah.
All right, cool.
Try to replicate a user experience and scale.
Oh, that's a good one. Replicating problems, replicating bugs. Yep.
Doing random stuff to try to break your code.
Random stuff to push the boundaries, see where your code can break.
QA, automated.
Automated QA. Yeah, great. Any other?
Documentation.
That's a good one. Automated documentation. That's a really good one, especially if you do a good job documenting your test. All good answers. So I took the sort of the general approach of saying, like, test is code that runs some code to check the validity, to check is something working or not working. Because unless you're running the code, unless you have like tools and analyzers to check the quality of your code and check how it is, you don't technically know. It's just little characters in a file, and it could be totally broken or it could work amazingly. And tests are designed to help you gain that confidence that what you've written is working. So I put up a why I would test, and we're going to have some overlap from your test definitions. So I think this might be a little bit of a repeat, but I'll go through it anyway. We want to prove that the code works. It's about proof. Getting some verification that the code does what we expect it to do. We want to, as Ken noted about documentation, a way I phrased it as examples of usage. So you can, if someone is looking at your test suite, they can see the way that you've written your code and how you've designed it in your tests and how you call it might be an indicator of how they can use it in other areas of the code base if you're working on a large team, a large project. And I'm sorry, I'm blanking on your name, Todd?
Yeah.
Yes, Todd, got it. Todd commented on regression and so this idea of a safety net for future changes, so that if you are working in some part of the code, you haven't touched it a long time, you get a new business requirement that comes in, and you have to go back to that chunk of code. You want to make sure that all of your old business requirements still validate, or maybe you're not a business, maybe it's just a hobby. Whatever your goal is, you want to make sure that you didn't break the feature set that you had defined in the past. And so tests can help you to preserve that, because you're going to find, inevitably, as your test suite grows and you covered more and more things and more features and use cases, that you'll make a change and you'll be surprised, oops, I broke something over here. And I wasn't considering that aspect of this when I was writing this code. So these are the kind of the three big tiers that I thought of when I thought of tests and why I would want to test. So we're gonna shift to a little bit to a pop quiz. This is intended to be responsive. This is a true and false quiz. There are not trick questions in here. I'm not trying to pull one over on you, but I'm gonna present a slide. I will ask the question, and then I will hopefully get a collective true or false. Everybody good with that? Yeah. All right, cool. Let's go. So is 42 equal to 42? True. Very good. Does 4 not equal to 2? True. Is 7 greater than 9,000? False. Excellent. Is 7 less than 9,000? True. All right, you guys are awesome. Is 10 greater than or equal to 10? Okay. Is 20 less than or equal to 10? False. All right. Is hello in hello world? True. Is security in IoT? False. All right. Yeah, exactly. That's why I put it up there. So here's the quiz. These are a bunch of assertions. In that time frame, you all have managed to learn the bulk of the PyTest API. Let me do that again. There's the assertions. Okay? We getting it? Got it? All right, cool. So you now know the bulk of the PyTest API, but I haven't taken the time to explain what PyTest is, and that's probably maybe bad form on my part. But PyTest is the most popular Python package for testing that's available on PyPI. Now, you may be debating me on, maybe unit test is blah, blah, blah. But I think that the industry has kind of coalesced around PyTest as the tool that you want to use when you're doing testing. And we'll see why, I think, as we explore this topic more. One thing that PyTest really has going for it is it's got a huge ecosystem of plugins. So as you're doing more complicated things with your tests, you are exploring some certain domain, there's probably a plugin or an extension that someone has written to try and help with that domain. So the way that PyTest is designed is a very extensible system, which makes it easy to write plugins and extensions for. And so there are a lot of plugins and extensions that you can use for various purposes. It's also not unit test. This is a debatable benefit. It depends on who you ask. And so let's dig into that a little bit. Why not unit test? So unit test, I guess I should preface, is the testing framework that is built into the standard library. So when you get an installation of Python, you don't have to install unit tests separately. It just comes with the system and is used to actually test a lot of the internals of core Python. So it has a long and venerable history. So it's a good, solid tool, but I'm not presenting it here tonight for a variety of reasons, but the biggest one is we took that moment, that quiz a second ago, to say assert is the way that you do testing in PyTest, and we'll dig into all that means in a minute. But that was your API, that's your hook. If you were thinking about PyTest, remember assert, and you're pretty much covered. Now, if we were doing a unit testing talk tonight, or the unit test module specifically, I'd have to go in through and explain a lot more API stuff. So PyTest has done some really cool things by making assert sort of this overloaded magic thing, and there's a lot of stuff hidden in under the covers of how PyTest works to do some rewriting of your code. So what you see as a basic comparison of equality or greater than or less than, there's some dynamic magic that's happening that PyTest instruments your code, your comparison checking, and it's what's able to give you rich diagnostics later when you will inevitably get some kind of failure. Unit test is not as magical, so the API is a lot more explicit. You have to explicitly tell it, I want to assert that this is true. I want to assert that this is greater than this, and so on and so forth. So it's that magic in PyTest lends itself to a very clean API when you're writing your tests. So this is maybe you're still in a disbelieving attitude here of are you kidding me? I have to write tests for my own code. Isn't that overkill? What's the point? Why would I want to do that? Hopefully the reason, the why that was presented earlier was a little bit compelling. And the next thing we're gonna do is we're actually gonna get into some coding so that I can prove to you, or at least demonstrate what I think is compelling evidence that this is not so hard. It's worth your time. It can shake out bugs. It can make a more robust code. So let's switch over to some code. So here we are. There is virtually nothing up my sleeve. There's nothing in this directory. We're starting from scratch. And if you wanted to follow along with coding and typing, and now's your time to do so, but you certainly don't have to. We are going to use Python 3 for this. This is just the recommended version of Python these days. Python 2 is ending support at the end of this year, so unless you have to, don't use Python 2. Yes, Joel, what's up?
Are we using like VS Code? Is that
Use whatever editor you're comfortable with. I'm going to use Vim just because that's my comfort zone, but you are welcome to do what you like. So to start, I'm going to create a virtual environment. I'm not going to dig into a lot of what this is, but just know that it's a directory where you can install packages and they'll be kind of localized. Virtual environments are a big topic. There's a lot going on in them, but it's a way that I can install one thing in one place and it be just particular to this little project or this little directory that I'm working in. So the command that I ran here was to tell Python 3 to use the virtual env module and create in the virtual env directory, which is the second virtual env, the directory of stuff. And now you can see that I've now got a directory and it's got some stuff in it. Again, not going to cover the internals of why that works, but that's the case. So virtual envs are the other thing that we'll have to do is we'll have to activate it. Using, we're sourcing with our bash terminal. This is where if you're using Windows, the way that you activate a virtual environment is a little different, but it's an activate.bat script, I think, if you're looking for it. So you can do the same thing if you're trying to follow along. So when you activate the virtual env, it tells Python and the interpreter to look specifically at the directories that are on your path, and that's about where I'll leave it at. So now we have virtual env activated. So you actually want to get pytest, and this is where unittest and pytest diverge. Pytest is something that you have to get from the Python package index, which is also known as pypi. And it's an external thing. It doesn't come with the language, but pip, the Python installer tool, is so ubiquitous now that it's pretty easy to go that route. I'm going to pay no attention to this step. I have Z shell that does some funny business, so don't worry about what just happened there. Okay, so now we have pytest available to us. And we're working with pytest version 4.3.1 here. So we need to talk about what it is we're going to be making. I designed this specifically with a terrible calculator in mind. The point of this is not to show you an exemplary design of some amazing class, some amazing API that should, wow you. The purpose of this is to show you testing interfaces. So I'm going for the lowest common denominator here. Don't ever write a calculator like this, I beg of you, but it's what we're gonna do. So, but before we even do that, we wanna, let's just try running pytest by itself. You can see the output of pytest listed here. It tells you what version of Python you're running with. It tells you what version of pytest you're running with. There's a couple of plugins that come with default. It just kind of gives you an indication of everything that it knows about your environment right now. And that's diagnostic information that it starts with. And the line at the bottom makes it very clear, we didn't run any tests. Duh, we haven't written any tests. So how does pytest know that we haven't written any tests? Pytest has a built-in discovery mechanism. So it looks at your current directory, and this is configurable, so you can change this, but the default thing it does is it looks for files that match the pattern of test underscore and then whatever you want to call it .py. And if it finds that kind of file, it assumes that that is a test file and it's going to look in there for test code. So let me bring up another shell and we'll create test calculator. Now, we're going to test how good my typing is while I'm talking. Probably not very good. So now we have a test file. You can see here. And we're going to run pytest again. There's still no tests because we haven't written any. But we now have a test file, a place to put our tests. And so over here, we are going to write a function. And I'm going to pretend don't know what I'm doing. So pytest, everything about it is writing functions, and the functions are doing the actual execution of code and assertions. We'll get into the guts of that. But if I started here and save this file and run it, you'll see it still said no test. So we're missing one aspect of test discovery. There's a test file name pattern match that's important. But there's also, the name of your functions is also important. So if we're over, hey Brian, if we're over here, we need to match that naming convention. So again, this is something that's configurable. So if you don't like how tests look when you have this, you can change this with the configuration file. But the default thing that we're going to do is, remember we're going to do a calculator, is to use test as your function name. And if we run it, cool. Now we get clear evidence that pytest has worked. Our test did nothing but assert that true is true, and it is, in case you didn't know. So we have one test, and pytest has made that one function was our one test. That's kind of the granularity we've got. So if I had, went back over here and I copied this and had two assertions, this does not suddenly become two tests. It's still a one function, but it passed both of those assertions. So that's the kind of the unit that we got out of this. Okay, so we're going to do a little bit of a TDD style, test-driven development style to make this, and we're going to make our terrible calculator. So the first thing I want to do is kind of show you the pattern that you want for even writing a test. So let's delete this stuff, and when you write a test, this is the way that I've read about, this is the way I like to think about it, is using a AAA kind of acronym. Your test should be divided into roughly 3 phases. The key one that we really care about is the assertion at the bottom, but you have to talk about what is it you're asserting. So where you get that what is from your action, which is like the core thing. So this is basically, can you take a guess on running a test add function? What's going to be the core action? Add. Yeah, not a trick question. Okay. And then arrange is setting up anything that needs to go before that action happens. Okay. So let's do that. Let's say we're going to have a calculator, and it's going to be a calculator class. So that's our arrange. And I personally like to give a little bit of white space between each one so it's very clear of what the sections were. And we're going to say add, and we're going to give it 2 parameters. Again, world's worst calculator. Don't design this, but it'll get the job done. And we're going to assert at the end 5 is equal to, or let's put it the other way, that the result is equal to 5.
Did you read the typo in the class? How you later?
No, I did not.
I thought it was part of the test.
It would have, yeah. I did design some mistakes in here, but not that one. Okay, so before I even run this, does this kind of resonate with people? Does everybody? I don't want to get off the rails before we even get started. Is it kind of clear what's going on? We're making a calculator. We're calling its add method with some parameters, or arguments, I should say. We got the result out of that, and then we're making the assertion that the result is an addition. Sound good? So if we come back over here, now this is the test-driven development aspect of this. So I declared something that clearly does not exist yet. Calculator has nothing. So I'm using the test to drive out what it is I want to make. I have a design in mind, and I'm kind of working backwards. You don't need to work to this granularity if you don't want to, but if you're doing like purist TDD, this is probably the approach that they would say to do. So I guess before I can get that far, I need to have a calculator module maybe, where I can import the calculator. Okay, so that's one more step. Again, small little incremental steps. That's the other thing that tests can give you the benefit of, is you can run them as often as you want to kind of prove that your code is doing what you think it is. So now what? So we got a new one, module not found. Well, we haven't made our test file, or our actual production code file, if you will. So let's bring up another terminal, and the only reason I'm doing it in 2 terminals is because this monitor is like so blown up in resolution that I can't fit it on the same thing, but we'll work with that. So calculator, new module file. What now? So now we don't have a calculator. Okay, let's come back over here and make our calculator class. I think I'll try and spell it this time. How about that? And we'll give it a documentation string, which is the formal name in Python is a doc string, and call it a terrible calculator. Okay, so this is an empty class. There's no methods that have been defined yet, but we have a calculator class that we can work from to get going. And let's run our test. Okay, we're still getting there. Calculator has no object, has no attribute add. Let's go add our attribute. And we want 2 operands. And let's go ahead and let's say A plus B. Okay. And this is the cycle we're just going to keep repeating until we get there. All right. If you're a new Python programmer, you will encounter this. If you start making the first class you make, you'll probably hit this. What I left out intentionally was that classes have methods, and there's a distinction. There's a subtle distinction here between a function and a method. A function is something that does not exist in a class. A class is a way to group behavior and data together, but a function is something that's intended to not keep track of any data. It's purely pass in some inputs, get some outputs. That's the ideal function. So when you have a function, you just get those things, but when you have a method, that's when you're in a class and you're defining what looks like a function, still using the def keyword, it actually becomes a method. And the way Python handles this is there is an implicit self thing that's passed in to the method as the first parameter. So what over here appears to be 2 arguments, 2 and 3, there's actually, you can kind of imagine it like, calculator itself gets shoved in as the first argument before the 2. If that makes sense. That's just the way the wiring of Python is. So when you have a method, you've got self as an option. All right, so let's try it again.
Matt,
Yeah.
is self defined? Like that's actually the thing that it is. It's not. You couldn't be like me.
Yes, very good point. Self is a purely conventional name in the language. It's not a magic keyword. I could have called that S. I could have called that me. I could have called that whatever I wanted. That's that. But just know that that first argument is the object instance,
Okay, cool.
which is why it's called self, because it is itself. All right, so I still have a failing test. Let's get to why. It says, and here's where, because pytest knows about your assertion and knows about your comparison check and is able to do this magic under the covers, it's able to clearly tell you what the value of result was and present it in a way that I hope is easy to understand. So what is our problem here? None is not equal to 5, so the assertion fails. Can somebody spot the problem?
You need a return.
Need a return, yeah. So this is not Ruby. We don't get implicit returns. You gotta explicitly return it. Let's see. Hey, a green dot. You start to crave these green dots as you do a lot of testing over time, because especially like a really robust test suite will have hundreds or thousands of them, and you just kind of get this like dopamine hit from just sitting there. It's like, give me the green, give me the green. Sorry.
Simple little joy.
Yeah, simple little joys. Maybe a simple little mind. I don't know. So we've now got our add function, or our add method. Excuse me. So that's our first test, and let's expand upon this. So I'm going to take this whole thing, and I'm just going to copy it, and I want our calculator to at least have 4 primitive operations. We're not going to go full-blown scientific here and get all of the exponents and all that stuff, but we are going to have the basics. So let's do what you learn in 4th grade math. We'll have a subtract, and we'll say, I don't know, 9, and that answer should be 6. Gosh, on the spot doing math. Okay, so I'm going to stop flipping back and forth to pytest because my editor has hooks that I can build in that I can call pytest from here. That way we don't have to flip the tabs all the time. So what you might have not seen there is it ran that top line directly from my editor. So it's the same thing as me switching over to the tab, but just to save us the time of going back and forth, that's what's going on. So I'm just running the test directly from the code file. You can see we don't have a subtract, so let's take this one and change it to subtract. And we're gonna this point's maybe a little boring, but
Why do we have 2 folders? Two files. You're switching between 2 Vim files.
I'm only switching between 2 Vim instances right now because the resolution's really low, and so if I tried to put it all on the same screen right now, you'd be like, oh, I can't see anything.
But you also, I think, in practice, you keep your test code separate from your feature code.
Yeah, they still end up being 2 separate files for sure. But yeah, I could have this in splits and you could see the code and the test file at the same time.
You could put your test methods in the same file as your feature methods and still have the test work, I think, but it would be a very bad practice because you want to keep your feature code separate.
Yeah, maybe. I guess you'd have to customize that. So I guess the question was for the recording later on is you could put your tests in the same file as your production code. So pytest would probably allow that if you change the pattern to say like, what are my test files? Remember, every test file starts with test underscore whatever. But if you change it to just be like, look at all the Python files and see if you can find tests in there, that would probably work. But then you couldn't use production code that started with test. Yeah. There's lots of ways to do it. So, all right. So we've got subtract, and I can run the whole suite. Now we've got 2 dots. Woo. So let's do, what should we do next? Let's do change subtract to multiply. So we've got a multiply function, and that's not going to be 6 anymore. That's going to be 27. I love somebody's answering over there. I love that, basic math table, sorry. So we don't have a multiply. So again, this is just a bit of copying, but I want to have something a little bit, just so you have a few dots to look at and all that. We've got 3 passing tests, hooray. And then one more. Let's change multiply to divide, and 9 divided by 3 is 3, right? So there's no divide, and I'm kind of going a little fast through this, so hopefully you can see it, but this is not really the super important part of what we're doing here, so that's why I just want to crank through this little bit of code. All right, so we have our test calculator file, now has 4 tests in it, and so what we've covered here for our calculator is the happy path, is the term that we sometimes use in programming, that we've proven that we can add, subtract, multiply, and divide if you're being a kind user. But if you've written code for long enough, you know that expectations will be violated, or your contract that you set out will not always be what you think it is. And let's dig into that next, because I think, I don't remember who was over here, might have been Ricky, that saying that, you know, you can do QA of automated QA of different kind of stuff. So let's do let's change this. Oops, excuse me. So let's make a new function, and this time we're gonna test our add with weird stuff. And I did have to change it, so each test name does have to be unique. And this is kind of a side effect of Python, really. The Python will go through when it puts the code together and generates the bytecode for it. If you have a renamed definition, it just like loses the old one. It doesn't keep any track of that. So if I didn't give this a unique name, it would have said I still only see 4 tests, or it might even complain. But let's test our weird stuff and change it now to, now we're still doing 2 plus 3, right? No, not so much. So our first weird example says you can't concatenate a str and an int. Okay. So another aspect of testing is you have to think about the error states of your code. Your API is not always going to be walking the happy path. So what happens when bad things happen? Python is a language that uses exceptions when exceptional things occur. So what I would like to do is I would like to change this test. And here's one bit of the API that I didn't cover. I said I covered the bulk of it, but there's something called raises. When you're in Python land and you want to create an exception, you raise it. You're basically like flagging down the caller and saying like, hey, I don't know how to handle this. I'm giving up. You handle it. That's what an exception is for. And so we want our calculator to raise a calculator error. So that's going to mean that anybody who calls this code in the future would receive this calculator error, and it's up to them to decide how to handle it, whether that means logging some information, printing something out to the user. In more advanced cases, you could maybe try and self-correct, like maybe it's something that's recoverable. There's all sorts of stuff that you can do in exceptional cases, but this is more of an illustration of here's an error case, and what do we do? So we're using pytest, and I guess that means I need to import pytest because Python is not magical about imports. So we have pytest, and we have this additional raises function. So that's going to, the expectation of this is we're using a Python context manager, which says that whatever runs inside of this block and this with block, it better throw a calculator error. It better raise a calculator error, or there's problems. And pytest, global name pytest, is not defined. Why is that? Oh, you know what it is? Got this. Sorry, I didn't activate this shell. Sorry about that. We'll get back to. So hopefully this will work this time for real. Okay, that's the error message I expected. So we haven't actually done anything yet in our real code, right? So, but this is defining the expectation. This is again more of that TDD, test-driven development style of this is how I would like this thing to behave, so that when it comes time to be used by someone, that it'll feel that way. So let's come over here, and we're gonna come to our add function. And so the thing that we're looking for was a type error, right? We were trying to concatenate a string and an int, and it doesn't like that. And so what we want to do is we want to raise a calculator error, which doesn't exist yet, but we'll go ahead and make that. And we'll just leave the message as blank, that's fine. So we have to make a calculator error too. So if you're making exceptions, they all have to derive so this is Python is a inheritance-based language. So this is the way you do inheritance with the parentheses at the top there. So we're saying like we're taking the exception and we're making our own custom exception here. And we'll call say as our doc string an exception class for calculator. Okay. So I believe that this will be enough to make our test pass now. Oh, I messed that up. What did I do wrong? Did I spell it correctly this time? Calculator. Calculator. Oh, over here, I need to import the calculator error. All right, cool. So I'll stop there for a minute because that's kind of a new concept. Does everybody follow along with what I did there? Do you understand a little bit of exception handling? Is that foreign to people? Like, do I need to go over any part of that more? I'm happy to if I need to try and explain it again or in a different way, I can do that. Yeah.
How would you handle different types of like exceptions? Like say the one is you tried to add a string to a number, like another one might be, let's say that was in divide, and then another one would be like trying to divide by 0 kind of thing. So
Mhm.
two different types of errors. You would want two different types of error messages. So how would you?
Right. So in Python, you can have multiple except blocks. So if, let's say, there was some other type of error, like a value error or something else that we expected to come in, and we wanted to have a different message. So in Python, you can put a message in your errors, like, hi, mom. Like, you can put that stuff there, and then you could have, different messages. Okay.
So in that case, Matt, you need to think of any possible scenario of what could go wrong in your code?
Yeah, that's the idea. A really robust design will have tried to think through the big things that can go wrong. So, we're doing a calculator, we're dealing a little bit with math, but let's say you're doing HTTP requests and you're using the requests library, and networks can fail, right? So you got to think about timeouts and connection errors and SSL error. There's a whole host of things that's badness that can happen, and a well-designed API, in my opinion, would try and think about all of those things and factor them in and provide useful information back to the user or the consumer, because maybe your client, maybe whoever's calling this, has no idea that you're talking to a network. And that's not really their business to know that they're talking to a network. So you want to put the proper design and abstraction in place so that what they receive is like a kind of like a business error or a logical error, rather than something down in the weeds of, what do you mean I got a network error, that my network wasn't there? I didn't know I needed a network, that kind of thing. So yeah, but we're not doing a ton of that with math, thankfully, but yeah, that's the concept. I'm going to ditch that value error thing for now because I don't think we need it, but yeah. Everybody feel good about that so far? Okay. So, yeah, that's weird, but let's make it weirder. Okay. Anybody have the opinion that this will throw a calculator error? It did not raise.
Because you're based on integers rather than string.
Yeah, well, yeah, you're onto it for sure. So, right. Well, what do we know about strings? Like, and we kind of got a hint out of it when there were two of them. String, and it used the word concatenate, right? So we can actually take the context of this, and I think we can do this. Well, you can just take my word for it at the moment. I'm not sure, because this is going to cause a failure, that you can use this as a context manager, and let's say you were trying, like the assertion, the raises did happen, but you still wanted to verify the message, the hi mom from earlier or something like that. You could take this context and you could take the value that's in here, which is the exception. And if you do a stir operation on it, it transforms the exception into its string representation. And you could say, hi mom. So you could also verify that even your error messages are what you expect them to be. That's not going to work here because this is not actually throwing the calculator error right now, but that's the idea. Okay, so we have a problem then. We're able to handle when one of them is not the right type, but when both of them are strings, that's problematic. So our approach here, while it worked partly, was not complete. So I think what I want to do is, I guess we needed to check the type of this, right? So we're going to say check, and these are operands, and this is a little helper method, and we're going to make it take an operand, okay? And I want our check operand, we're going to check if we're a calculator, so we care about numbers, so we're going to say is instance, so is the operand an instance of numbers number? And if you're not, then we want to raise a calculator error. And what can we say? We'll do this. Operand was not a number. And I'll break this down in just a second, because I know it's a bigger chunk of code. Okay, so we've got our helper method. The way that we're going to use it is, rather than do this type error checking up here, we're going to call check operand with A and check operand with B, because those are our two operands. And so now, hopefully this is a little clearer. So Python is usually of a model where it says, like, just do something and let it fail. But there are valid times where you want to do the checking in advance, which is exactly what we're doing. So it's coming in and we're passing A into our check operand method. We're checking if you're a number, which is a standard library I frankly had forgotten was there, but it's kind of, number represents, is like an abstract thing that represents float and real and decimal. Like, all of those can fall under that category of number and integer. Sorry, I've left out the obvious one. So any of those should pass that test. But if you don't pass that test, like you're a string, I wanted to basically elevate that and give it an indication of this was not right. And the other cool thing that I used here, since we're in Python 3.7, is this is an example of an F string, which you can, just by using the curly braces and passing in a variable name, it will automatically do that, rather than doing dot format operation or string interpolation, if you're familiar with those. So let's see if it worked. Hooray! So that means our test passed, which means that it raised a calculator error when the types were not numbers, which is cool. And you know what? Now is our time that we can see. Let's check out that context and see what it was. So I want to take this context and check the value, and I want to see it fail. So I'm going to put in wrong. Okay. So our message back was 2 was not a number, and cool. We got a nice friendly error message. Okay. So we've covered, what have we covered? We've covered happy path. We've covered a little bit of error checking. I think maybe it's time now to prove that this code works. And to illustrate a decent point. So if we start Python, we can, from the calculator module, we can import calculator. And I'm going to just call it C this time. We'll create a calculator. So C add 2, 3 is 5. And I brought up the REPL, the read, evaluate, print loop, just to show that this test area is not magic. It's just Python code executing Python code. So it's the exact same stuff that if you had it in your production code, it would work the same way. If you have it in the REPL here, you can see it running. It's the same. So that gives you a lot of confidence that if your tests are passing, your code's going to work the way that at least the way the tests say. That's not to say you don't have other bugs, but it's working. So I thought for maybe the kind of finish this off, we could make a quick little user interface for this, for our calculator, to make it interactive, and kind of see if we can shake out one final bug that's in here, and then that will kind of wrap us up for the evening, and then we can explore any questions that you all have if you have more. So we've got our terrible calculator, and I'm going to do the if name is equal to main trick. It's not really a trick, it's well known. This is a little bit of Python jargon that says if you run this Python file as Python, this is the thing that will run. Okay? So this is where we want our interactive calculator. So let's say, let's calculate. And our calculator is going to just work in an infinite loop. And it's going to give a text user interface that says pick an operation. And you pick the operation by a number, and we'll be able to quit. And it'll perform the operation and print it out. That work? So to start, let's say while true. So that's going to be our infinite loop. And we need to give the prompt for what to do. So pick an operation. And what else do we need? We're going to need our operations to work on, right? So let's do a list. Oh, I guess even before that, we need a calculator. So we'll have a calculator. And we're going to do like this. We're going to do calculator add. And we're going to take advantage of the fact that functions, or methods even here, this is a bound method, they're like first-class objects in Python. So I can assign these as just things that go in the list, and this is totally okay. Whoops. So we've got our 4 operations that we want to work with, and now we need to print them out. So we're going to loop over them. We're going to do a print, and we're going to use the built-in enumerate method function that's available to give us a number that we can get as well. So I'm going to call that I, because that's kind of conventionally what it is. And the second thing will be operation. And enumerate. But we don't want this to be like terrible programmer zero indexed stuff. So there's an extra thing that you can pass to enumerate, which is start. So you can tell it to start at 1. And then we want to do, what do we want to do? Let's say I, and then we'll just do a colon with the operation name. So functions, you can also grab their name, that you can reflect on them and very easily pull out what the name of the function was, which will just be add, subtract, multiply, divide. And that's going to infinite loop on us, so let's do this. Whoops, I think I wanted this up down below, sorry. So pick an operation. All right. So this code, let's logically think about it before we actually run it. It just prints out, let's evaluate, and then we get into this infinite loop. We've already pulled out all our operations. It's going to display the list of operations that we want to be able to provide. And then input is, this is the reason why this infinite loop is not going to like spin on us and rev up my computer to, very hot by using a lot of the processor. Because input is a blocking function, which will just present the prompt, and it will take the operation or whatever you pick, and then we can actually work with it. So now that we have it, let's try it out. Come on. So Python calculator, did we get it? Okay, cool, that much works. This is a lesson I learned in college that's really valuable. As you're writing code, run it often. Do not wait until you think you have the whole thing working, because you will break stuff. So the short little feedback loops, like we haven't done a lot so far here, but I think it was just enough code that to make something interesting. But we're not doing the whole user interface in one go. But I think that's a good thing to get little nuggets so that you have confidence all the time. You always want to have confidence that your code is working. And I guess maybe we should have a print, let's just say Q for quit. Yeah. Yes?
It's another reason to write tests, because you can run smaller pieces before you finish.
Absolutely, absolutely. Yeah, I should note, if I was doing this, if this was like a real user interface that I cared about, I might be writing tests for this too. This is just enough of like a harness to see our calculator kind of work in action and show off one final bug in it that we're going to focus on. So if our operation is equal to a Q, let's just do a sys exit here, and then that means we need the sys module up here. So nothing's happening yet, but we at least have the ability to quit, which is good when you're in an infinite loop. So the next part of what we want to do is, I'm going to assume that our users are being nice and sticking to those 5 options. So I'm going to cast the operation to an integer, because I'm going to use it as an index into the loop. So we started at 1, and we're going to look at our operations in order to get the thing to run. It is operations at our op -1, because Python's a 0-based language. And we're going to need our A and our B. I guess we should ask for those two. What is A? Place of B. Now these are strings, so if input returns strings, so this calculator currently will never work, because we have the check on, or it won't work for addition, I should say. So let's just assume again that our users are being nice, and they're always giving us things that look like numbers. These are terrible assumptions if you're actually writing something that you want to not fail on users, but we're trying to do this. So what did I just, let's talk about this, what did I do? So we've got our operations, which are a bunch of methods, and because they're from the calculator instance, they're bound together already, so that the instance is already there. We can just use it, we can kind of use it like a function. It's less useful here because the calculator has no state, but if you made a class that did have state and you wanted to do that and use pass around methods, bound methods, you can do that, which is kind of cool. So we're going to ask for the 3 things, the operation itself, the A, the B, and then we're going to look up the operation which should be, an index of 0 for add, 1, 2, 3. And then we're going to go ahead and call it. We're immediately calling it straight from the list that we have there. I think I did all of that correctly. Let's see how true that is. So let's say add, what is A? It's 4. What is B? It's 5. Then print it. So maybe it did the operation. I don't know.
It's a terrible calculator.
It's truly a terrible calculator. You nailed it. So we've got 4, 5, hey, 9. It's a floating point number now, which is why it's 9.0, because we converted them explicitly to 9, but yeah. All right, ways to break this calculator.
Divided by 0.
That's the one I had mine immediately. So we're picking 4 to divide, and we're going to pick the answer to life, and then we do 0. Ooh, 0 division error. Okay, so this is an example now of, your client you're a contractor and you've delivered your terrible calculator, and they've said, oh, this is great, and they've plugged it into their system, and they hit a bug, and somebody made a note about like reproducing stuff. I don't remember who it was. I'm sorry. But here's our chance to reproduce this and write a test that reproduces stuff. So coming back over here, let's write a new test, and we're going to say test divide. Let's call it divide by 0, and we'll take that and we'll change our second operand to 0, and I want to expect it to raise our trusty calculator error. That's my expectation about what should happen. I think we all know that that's not going to work. Instead, we're going to get a 0 division error. So now we're being driven by test, and we get the added benefit of we've improved our test suite. So in the future, if someone crazy is like, oh, you can divide by 0, it's no big deal, and like rips out the code that we have to handle it, then a test will fail and say like, wait a minute, you said that this is the contract and between this and your clients, and you didn't uphold that anymore. So what's going on? So we'll come back up to our divide, and we're going to say try except 0 division error. Good, I got it right. We're going to raise calculator error of can't divide by 0. It's going to be our nicer, friendlier error message. Okay. Test passed. Always test your stuff. This is still an error that appeared, like our user interface didn't actually catch it. So you made a contract, but no one followed it. So there's a failure here as well of, like, imagine if you're like a regular business user, you're not a programmer, and you see this thing. This thing is terrifying. Like files, code, like I'd be horrified if I wasn't a programmer. So what we fail to do is when we actually execute the operation, we didn't think to print out what happened, if there was an error. So we're going to take our error and we're going to capture it as an exception and print it out. So now 42, 0, okay. The system didn't break. We're back in our loop. We got the error message, which is what we want. And I think that, it's still a terrible calculator, but it's a calculator that's functional. I'm sure we could probably keep poking at it and find other examples. Like I could give you, oh man, let's see if I can find another one off the top of my head. So what if we did,
Enter 5.
Hmm?
Enter 5. I mean, it doesn't break.
Oh yeah, that's true.
The domain of the calculator.
Yeah, it won't break it until we do, and we'll get an index error here, right? So yeah, there's still problems. But this is, again, you go back, this is just an iterative cycle at this point of I've got something that's basically working. I need to write a test to prove that I can fix this problem so it won't be a problem in the future. So you can kind of riff on that for a long time. So that is our sample code. And that's what I've got to present tonight. I'm happy to take questions and talk about what other things you want to see or explore. Yeah, Brian.
So I guess one question it's probably way bigger than the topic that we just mentioned, but that user interface part looks like the place where I would want to code a whole bunch of automated tests. But how can you, is that a whole different harness or something where you want to throw a bunch of different stuff at where it's prompting you for input?
Yeah, so the way I would approach that, and the way I have approached that in other projects is, I threw all that code in one place. Infinite loops are really hard so to deal with in running in test harnesses. And anytime you get into a while true, that's one code smell right there that probably shouldn't have written while true. Maybe you should have an escape hatch of putting it in a variable, and then, but even then that's still hard. So what I'd probably do is take the guts of that while true and extract that into a function and be able to pass in or test through one iteration of the function and kind of work it that way.
Okay.
So yeah, there's always this top level of you're dealing with either event loops or you're dealing with browsers. I mean, there's all sorts of places where testing can get hairier. And pytest, while it can also do higher level testing, what we might call integration testing or system testing, which I'm not really covering so much today, versus this is very much unit tests.
Okay.
So it's all in your test strategy, I think. But that's a good way to do it, is to decompose it into smaller pieces and have each of those pieces be digestible, testable. So you have to think about testing, making your design testable from the get-go. You can definitely write untestable code, which is really tough.
Okay.
So,
Cool. Thanks.
yeah. Other questions? Yeah.
Assume that, I got somebody asked me to refactor a legitimate figure function,
Mhm.
and no test. Function really spaghetti, a couple hundred lines with a lot of if, then else, and all that. How would you start to build tests before
Oh.
you make changes?
So the question was, how do you add tests to an existing function that has lots of logic, lots of lines, and is very tricky? I think Patrick wants to take a crack at it.
Matt gave me this pointer a couple weeks ago. Just see if the code will actually run inside of a test that calls the class. That could initially, I guess, be maybe I perceived that wrong, but being able to actually just load the code inside of a test and have it return arbitrary values that are going to be the same every time, but at least be a start, so that if you make some changes to the code and all of a sudden that one test fails, you at least have a breakpoint there.
Yeah.
I work in a cloud environment. There's a lot of things that create, and then you try that, you're going to actually create stuff, and it costs money. So
Yeah.
how would you?
Yeah, so there's whole books written on this topic. I'll recommend one. Michael Feathers is the author. He's written a book called Working Effectively with Legacy Code. And the idea behind that book is for exactly the problem you're highlighting, which is that code that was not designed for tests, that is really huge and is hard to get in test harness, is the kind of the terms we use, and is hard to get in, even wrangle into an automated test suite. How do you work with that? And there's a lot of patterns of the introduction of a concept called seams, and it's a pretty deep topic. I do like Patrick's initial suggestion of, can you run a large chunk of tests and even get code coverage on it, get it to even execute? That might be a starting point. But if you're down in I need this thing to be in this condition, and this thing to be in this condition, and this thing to be in this condition, and so on, in order to get to that one line of code that you're trying to modify or refactor, that ends up being tricky. It's a bit of a chicken and egg of like, my code doesn't have any tests and I'm afraid of it breaking, but in order to add the test, I need to change the code to do it. So again, Michael Feather's book is a really excellent resource for having that conversation about how do we slowly introduce tests into code that's not designed for it. But there's a lot of strategies to that.
I've seen some functions that have a lot of if and else and parameters have a bunch of them optional and this.
Yeah.
And how you, so many combinations of things.
Right. Your test could, I mean, if it is all your inputs are in one place, it's theoretically possible for remember the pattern is arrange, act, assert, to get the right arrangement of all of the preconditions, all the right states in line, so that when you act on it and pass them all in, you can get to that one line and isolate it as a test. Maybe that's a good first step of, if it's already got the stuff that it is truly testable. It'll be a gnarly test, I'm guessing, but start there, get it, make sure that it's hitting the line that you care about, and then you're kind of free to make your code change to add whatever functionality you needed. Yeah. Any other questions?
One more.
Yeah, go ahead.
If you have a new project and they have a junior developer, how would you give the requirement in English and then he write the test and then he build the code, or how would you go about it? Or you write a test and then ask him to implement the code for that?
So is your question, how do you translate business requirements into tests?
In the real world, how, you know?
Okay. That's really tough. There's been a lot of thoughts about, yeah, there's been a lot of strategies for doing that kind of thing. Some people will go so far as to use a kind of a domain-specific language where business people are writing acceptance tests that if you pass these high-level tests, I think like Cucumber is a popular tool that kind of does this. If you pass these sort of prose text tests, then you have a sign-off, a verification that my feature worked as I said it should. There's a lot of debate on if that is a good strategy. So, I don't often see a direct correlation between what you write as tests and business requirements. Sometimes it's really clear. Sometimes it's like, I need to add a feature. I can check if it does this and this, then the feature is added. Yay, verily, I'm done. But sometimes it's not so clear.
What's your working environment?
Sorry?
In your working environment, I think you're a senior guy. You probably have a business person say, this is a feature I want, and they kind of trust you that you do the feature and the tests that are needed in order to...
Yeah, that's true. The product people in my work environment, so I work with product engineers or product designers or whoever, and they're kind of scoping out some of the business requirements. They don't care at all about the tests. I mean, they want code quality to be high, and the side effect of making high quality code is that you've tested it well and write those tests. So, but the actual guts of like, am I writing the right tests? That's not important to them. So we don't take the Cucumber route where we are, or that kind of high level acceptance test route. But I'm not going to knock it because I haven't tried it professionally, so I can only give you secondhand knowledge of how well it works or doesn't work. Yeah, Chad.
I would just kind of add related to that. I mean, working on a team, you can have continuous integration tools that if somebody's adding the code that literally they can't merge it unless it has so much test coverage. So, that's kind of a nice way for like a junior developer. It's like, well, hey, this is, you have to meet this before I can accept your work. So it's not necessarily the business requirement, but working with others.
Yeah, continuous integration is really the manifestation of the safety net. It is what it sounds like. It is code that it's some place where you can run something continuously on changes that happen. So it's an opportunity to run your entire test suite. You get more value out of it, the better your coverage is, because you can have more confidence that you're not breaking large swaths of your system. So if you have like 10% coverage, I wouldn't put a lot of stock into your pass-fail on your continuous integration, maybe. But if you have to start from somewhere, it's better than nothing. But yeah, always have a passing test suite is good advice to make sure your code quality stays high. Any other thoughts? Awesome.
So test cases are pretty exclusively for the back end, correct?
No.
Because
It's totally possible. So the question was, test cases are exclusively for the back end, and I would wholeheartedly disagree with that. There's a lot of front-end testing frameworks. The JavaScript ecosystem is full of them. Jasmine, Jest, Mocha, Selenium, like, yeah, take your pick. There's way more than that too. That's just off the top of my head. So you can certainly write tests to test out front-end functionality. You get into some of the same challenges of like, what's a unit test? Like, what am I trying to test in this core versus a behavioral pattern that you might have in your UI, and that becomes a bigger test, and there's like issues of brittleness and all sorts of stuff that come along with that. But I think you can definitely have a very robust front-end test suite as well. Any other questions? Awesome. Well, thank you very much.